Mathematics Air Force Golden Jubilee Institute, and today our topic is conic section, and that too parabola. We'll be doing the initial part of parabola. Now, what is a conic section? What is a conic section? Conic section are curves which are obtained on the cone when it is intersected by a plane, right? So, see, if this is a plane, right? Now, we first draw a cone. The actual shape of the cone is like this, right? And it will not be restrictive. It will keep on increasing in both the directions, right? Now, if you intersect this cone with a plane, right? And if, let us say, this is, what is this line known as? Axis of the cone. This line is known as the axis. And what are generators? Generators are the lines on the surface of the cone. This is one of the generators. This is another generator, right? Now, when a plane intersects the cone, it can intersect in so many different ways. One way is this is the axis. The plane can be like this. It is inclined in this manner. Then what will be the point of intersection of the two, the plane and the cone? The curve which you will obtain will be of this shape. No, it will not be circle. Yeah, it will be elliptical. So this curve is an ellipse. So therefore, ellipse is one of the conic sections. Actually, it all depends upon the angle which the plane makes with the axis. Now let us say this angle is 30 degrees or 45 degrees. Then you will obtain an ellipse. Now in case this plane becomes perpendicular to the axis, then what will you obtain? We'll obtain a circle. So circle is also a conic section, like this. A circle will be obtained, right? When the plane is perpendicular to the axis. And when you will obtain a parabola, if the plane cuts it like this, right? See, what sort of curve will be formed? The common points will be like this. Or if this part is being cut, right? The point of intersection of this plane will be a curve of this form, and it will keep on opening up. So a parabola will be formed. Now, finally, you can have hyperbola as well. Hyperbola you will obtain if you cut it parallel to the axis. If the plane is parallel to the axis, see, if the plane is like this, then what sort of curve will be formed? An hyperbola. The shape of the hyperbola will be like this, right? So in fact, this sort of a curve will be formed. Now all of them comes under conic section. You can have the intersection of the plane and a cone can be a pair of straight lines as well. When you will have a pair of straight lines, if the plane is cutting in such a manner that it passes through the vertex, this is the vertex. If the plane passes through the vertex and it cuts it like this, then you will have a pair of straight lines. So a pair of straight lines can also be formed. You know, as a special case, you can also obtain a point. If the if the plane not necessarily horizontal, if the plane cuts it like this, passes through this point, then you will get a point. So besides the parabola, circle, parabola, ellipse, hyperbola, you may get a pair of straight lines. You know, the pair of straight lines will be on the surface of the cone. What else you can obtain? Think about it. So basically today we'll be focusing on parabola, ellipse and hyperbola. No, we are taking up the conic section. In the conic section we'll be dealing with these topics. Today we'll be taking up parabola. Now in all the three conic sections, there is a focal directrix property. It is a locus of a point which moves in a plane in such a manner that the distance of the point from a fixed point is always equal to the distance of the point from a fixed line. It bears a constant ratio. See, if in this particular case there is a point P, right? There is a point S. What is this point S? It's known as focus. And there's a line. This line is known as directrix. So in all the three conic sections, parabola, ellipse and hyperbola, it is a locus of a point which moves in such a manner that the ratio of the distances from a fixed point to a fixed line bears a constant ratio. That ratio is always constant. And in case of parabola, that ratio will be 1. In case of ellipse, the ratio will be less than 1. And in case of hyperbola, that ratio will be greater than 1. So specific to parabola, that ratio will be 1. In other conic sections like ellipse and hyperbola, the ratio will be different from 1. If it is less than 1, it will always be an ellipse. If the ratio is greater than 1, it will always be an hyperbola. And for hyperbola and ellipse, the ratios can be different. It is not fixed. But for parabola, the ratio E is eccentricity. What is this ratio known as? Eccentricity. Ratio of any point on the parabola from the focus divided by the distance of the point from a fixed line known as directrix. This ratio is known as eccentricity. And in case of parabola, eccentricity is equal to 1 because the distances are equal. So finally, see, these are the three eccentricities. Now, next. Now see, the definition of parabola is, a parabola is a locus of a point which moves in plane so that the distance from a fixed point called focus is always equal to its distance from the fixed line known as directrix, and hence eccentricity is equal to 1. Now we come to standard forms of parabola. Eccentricity is 1 in parabola because it's not mentioned. No, then yeah, so there is some error here. Eccentricity is 1 in case of parabola and less than 1 in case of ellipse and greater than 1 in case of hyperbola. Is that clear? See, from the very definition of parabola, you can make out that the eccentricity for parabola should be less than, the eccentricity for parabola should be equal to 1 because the two distances are equal. See, look at this. If you take the standard forms, first form is y square equal to 4ax, right? Let us say this is our x-axis and this is y-axis. This is the origin. The shape is like this. This point origin is the vertex. In standard form, origin is the vertex. So coordinates of vertex are right. Now if the coordinates of focus are taken as, focus is a point lying on the axis. If the coordinates of focus are a0, then the directrix will be here, and it will pass from what point? This point will be minus a0, for the simple reason that every point should be equidistant from focus as well as directrix. So these two distances will be equal. So if this is a0, this is the origin, this point will be minus a0. So what is equation of the directrix here? Any line parallel to y-axis is x equal to constant. So this is x equal to minus a or x plus a equal to 0. Is that clear to you? So vertex is 0, 0. Focus, I am assuming some point on the x-axis which is a0. Then equation of directrix will be x equal to minus a. Now how to obtain the equation of the parabola in this standard form? You take an arbitrary point xy, take an arbitrary point xy, you find out its distance from focus, and you find out its distance from this line directrix and equate the two. Solving it, see what is this, the distance ps? Ps is x minus a square plus y square square root. So I can just write ps square. Now what about this distance pm? See, since the distance from y-axis is what? X coordinate. So x coordinate is x here, assuming it is positive. That is, it's being in the first quadrant, so x is positive. And what is this distance? A. This distance is a. So this distance will be a plus x, right? So ps, now pm you know is a plus x, and pm square will be, so when ps is equal to pm, ps square will be equal to pm square. You solve this now. ps square is equal to pm square. So x minus a square plus y square is equal to what? X plus a square. Now solving this, what you will get? Y square is equal to x plus a square minus x minus a square. So y square is equal to 4ax. Y square is equal to 4ax. This is one of the standard forms of the parabola. Is that clear to you? Straight line? Pair of straight lines you can consider. See, you will not get one line when you find the intersection of a plane. When you find the intersection of a plane with a conic section, you will always have two lines. See, the reason is, suppose the plane is cutting it like this. So you will have one line in this form, and if the plane is inclined like this, the other line will be on that side. It will also pass through this point, and it will be like this. You're getting my point? So there will be two lines, not one. So pair of straight lines is also a conic section. See, there are some degenerate solutions. When the plane is taken in a manner, it cuts it at just one vertex, then it is a degenerate solution. Otherwise, parabola, ellipse, hyperbola, and circle. Next. Now see, standard form of parabola, y square equal to 4ax. Vertex is 0, 0. Clear? This is a vertex. Coordinates are 0, 0. Focus in this case, we started with what? A0. So coordinates of focus are A0. Focus is A0. Is that clear? This is S, denoted by S, and the coordinates are A0. Now see, if the shape of parabola is like this, how to obtain the equation of tangent at origin? The tangent at origin is obtained by equating the lowest degree terms equal to 0. So if you consider this equation, what is the linear term here? X. Lowest degree term is x. So you equate x equal to 0. What is x equal to 0? Y-axis. So tangents at origin you can obtain by equating the lowest degree terms in a curve equal to 0. So x equal to 0 is the equation of tangent. Is that clear? Equation of the tangent is x equal to 0, which is y-axis in this case. And it is a universal formula you can apply for any curve. If you have to find tangents at origin, you can just equate the lowest degree terms equal to 0. Focus is A0. Now axis of the parabola, this line is known as the axis of the parabola. Axis of the parabola is a line which is symmetrical to the parabola. This is a line of symmetry. It is known as the axis of the parabola. How to obtain the equation of axis? Y equal to 0. The quadratic term you equate equal to 0. So equation of the axis is y equal to 0, and y equal to 0 is x-axis. What is the double ordinate? Double ordinate is a line perpendicular to the axis. Double ordinate, this is a double ordinate. It is perpendicular to the axis. Any line perpendicular to the axis. Now focal chord. Who will tell me what is the focal chord? It is a chord passing through the focus. See, the name suggests focal chord is a chord which passes through the focus. So in this case, if this is the focus, right, this is the focal chord. This is one of the focal chords. You can have so many different focal chords. This is a focal chord. This is a focal chord. If you can just extend this, this is a focal chord. So focal chord is a chord passing through the focus, A0 in this particular case. Then comes latus rectum. What is latus rectum? Double ordinate passing through the focus. Passing through the focus. Or you can say a segment passing through the focus and perpendicular to the axis. It is a segment which passes through the focus and perpendicular. It is the intercept between the parabola. See, again we can look at this curve. If this is the, it has to be symmetrical. So we have to draw it like this, right? So this is the focus. If you draw a line, it is a double ordinate passing through focus and perpendicular to the axis. So let us say this is LS L dash. So what is LS L dash? Latus rectum. And what will be the length of this latus rectum? LR latus rectum. It will be, if the equation is y square is equal to 4ax, what you do is just take the coefficient of x and take its modulus. That will be the length of the latus rectum. And what will be the equation of the latus rectum? It is a line passing through the focus and perpendicular to the axis. So what will be its equation? X equal to A, because this point is A0. So equation of the latus rectum is what? X equal to A. Length will be 4A. This distance will be 2A, and the distance will be 2A again. So the total length will be 4A. Is that clear to all of you? Now, what are conormal points? from a point outside a parabola, you can draw three normals to it. From a point outside a parabola, you can draw three normals to it. So the coordinates of the fit of the perpendiculars are known as conormal points. And there's a property of conormal points that the sum of the y coordinates of the three conormal points will be equal to 0. What are conormal points? Three normals which are concurrent, which passes through the same point, right? You draw three normals which are concurrent, passing through the same point. Now the points where you have drawn the normals, you find there, those are the conormal points. They are on the parabola and the sum of their y coordinates will be equal to 0. We'll take up these conormal points later in detail. So what is the diameter of the parabola? See, you draw parallel chords. Draw any parabola and draw parallel chords, right? Let us say this is a parabola. These are parallel chords. You find their midpoints. Midpoint of this, right? And join them. This line is known as diameter. So what is diameter? It is the locus of midpoints of the parallel chords to a parabola. You draw any parabola, draw parallel chords, you find their midpoints and join them. That line is known as diameter. And diameter will always be parallel to x-axis in case of y square equal to 4ax. Is that clear? Now, quickly for y square equal to minus 4ax, you write down the coordinates of focus, vertex, equation of directrix, centricity is 1 in all cases, and the length and the equation of latus rectum. See, y square is minus 4ax. This will be the shape. Y square equal to minus 4ax. What is the vertex? 0, 0, right? What are coordinates of focus? You take coefficient of x and divide by 4. Take coefficient of x, divide by 4. So minus a 0. And what will be the equation of directrix? Yeah, if minus a coordinates of focus are minus a 0, just change the sign. Because in case of standard curve, if minus a 0 is the coordinates of focus, directrix will be somewhere on the other side. So equation of this line will be what? X is equal to a. Now what else? What is the equation of latus rectum? X equal to minus a. And length will be again 4a because we will take modulus of this. Is that clear to all of you? And what will be the focal chord? This is one of the focal chords. You cannot find the equation of focal chord. Focal chord you have to just define. Until unless some added information is given, we cannot find the equation. Right? Now, for x square equal to 4ay, again you write all these. For x square equal to 4ay. Since x square equal to 4ay is symmetrical about x-axis, it contains even power of x, therefore it will be symmetrical about y-axis. Symmetry will be on the others. Even power of x is there, it will be symmetrical about y-axis. This is y-axis, x-axis, origin. X square equal to 4ay will be like this. Now what is the origin? Vertex, vertex, yeah, focus 0 comma a. An equation of directrix, it will be this line parallel to x-axis. So y equal to minus a. Just change the sign here. Now this will be what? Line passing through focus and perpendicular to axis. This is latest sector. So you will write it as ls l dash. Its length will be again 4a. And equation will be y equal to a. Next please. The parametric equation of the parabola y square equal to 4ax is x equal to 80 square and y equal to 280. X is equal to 80 square and y equal to 280 depends on the parameter t, and every point on this parabola y square equal to 4ax can be written in this form. X is 80 square and y is equal to 280. And if you substitute in this, see, left hand side is y square and right hand side is 4ax. So in place of x you substitute 80 square. What you get? 4a square t square. This is 4at whole square. This is nothing but y square. 280. Yeah. Is that clear to you? Parametric form. Now, how you will find tangent to a parabola y square equal to 4ax on a point which is given on it? Tangent to the parabola. Parabola is y square equal to 4x, right? There is a point x dash y dash. For tangent at the point x dash y dash, what we do is y square becomes y dash, right? Remember this, y square becomes y dash, and x becomes x plus x dash by 2. Y square will become y dash and x will become x plus x dash by 2, or you can just write 2x equal to x plus x dash. So what will be the equation of the tangent? Y dash is equal to 2a x plus x dash. Is that clear? So if the parametric form, if you have to find, if you take the point as 80 square, 280, then what you can do is you can substitute. In place of x dash you put 80 square, in place of y dash you put 280, and this will finally give you ty is equal to x plus 80 square. Next. Parametric means the coordinates of you are defining the parabola in terms of the parameter t. So the x coordinate will always take the form 80 square and y coordinate will take the form 280. For different values of t you will get different points. So what we have done is, if the point is x dash y dash, what is the equation of tangent? Y dash is equal to 2a x plus x dash, right? And in case of parametric, in place of y dash you put 80 square and in place of x dash you put x dash 80 square and y dash 280. Then this will be the equation of the tangent. Now condition of tangency. Next, y equal to mx plus c is a tangent to the parabola y square equal to 4ax. Then the condition is c is equal to a upon m. Condition of tangency is c equal to a by n. y equal to mx plus c is tangent to y square equal to 4ax if c is equal to a upon m. See how you can determine this? In place of y, you substitute this value. So you will get mx plus c whole square is equal to 4ax, right? This is a quadratic. In case of a tangent, the point of intersection will be such that the two roots will coincide. You will have a common point. So what you do is you find the discriminant of this and equate it equal to 0. On equating the discriminant equal to 0, you will get c equal to a by m, right? Simplify this. What will be the discriminant? M square x square plus c square plus 2mcx minus 4ax equal to 0, right? Now this will give you one root if discriminant is 0. So what will be the discriminant here? You equate b square minus 4ac equal to 0. So what is b square? You can first write it like this: m square x square plus 2mc minus 4ax plus c square. So b square minus 4ac equal to 0, you will get c equal to a by n. Just remember this condition. Y equal to mx plus c is tangent to the parabola y square equal to 4ax if c is equal to a by n. And what will be the equation of the tangent? Y is equal to mx plus a by n. This is the equation of the tangent. This is the condition of tangents. Now, the chord with midpoint x dash y dash of the parabola y square equal to 4ax is s1 equal to t. Suppose you are given the parabola y square equal to 4ax and you have to find the equation of the chord for which x dash y dash is the midpoint, right? Then what will be the equation? S1 equal to t. I just explain you what it means. Chord with midpoint, write down chord with midpoint x dash y dash to the parabola y square equal to 4ax is the general result, s1 equal to t. This will give you what? Equation of the chord. Now, what is t? T is that same condition of tangency. What will happen? First you write this equation as y square minus 4ax equal to 0, right? Then what is t? Y dash minus 2a x plus x dash. This is your t. And s1 is very simple. Just substitute x dash y dash in the equation of the parabola. So what it will be? Yeah, y dash square minus 4a x dash. So solving this, you will get the equation of the chord having midpoint x dash y dash. Is that clear to you? This concept. Like for example, let us take midpoint as 1, 2. 1, 2 is the midpoint. And the parabola you can take as y square equal to 12x. This is the midpoint. What will be the equation of the chord? So what we'll do is, first you write it like this. All terms you write on one side. In place of x you substitute 1. In place of y you substitute 2. What this will give you? S1. What will be S1? 2 square minus 12 into 1. Right? Minus 8. And right hand side will be what? Y dash. So what is y dash? 2. Right? Y dash minus 6 and 2x becomes x plus x dash. So solving this is the equation of the chord. You simplify this. So what you have to do is on one side, you will write S1. Just substitute the coordinates of the point in the equation of the parabola. You will get a constant which in this case was coming out to be -8. Right? Now on the right hand side, you write in place of y square, you write t by y dash will be 2, so 2y minus 12. In place of x, you write x plus x dash by 2, or you can take 2 outside. So 2x you replace by x plus x dash. So this is the equation of the chord. Chaliye, next. This is an incomplete question, so see, centricity of the parabola will always be 1. Whatever be the equation of the parabola, its centricity is 1. Because what is the centricity? Ratio of you take any arbitrary point on the parabola, its distance from focus divided by its distance from directrix. And in all parabolas, the centricity will be 1. If it shifts from 1, it will no longer be a parabola. So this equation, the question which was asked, if it is a parabola, its centricity is 1. There is no need to do any calculation. Now diameter of the parabola, the equation is y equal to 2a by m. Y equal to 2a by m. See, equation of diameter. What I told you, diameter is the locus of the midpoints of the parallel chords, right? If the equation of the parabola is y square equal to 4ax, equation of diameter will be y equal to 2a divided by m. Just remember this, y equal to 2am is a line parallel to x-axis, and this is the equation of the diameter. Like for example, if y square is equal to 8x, right? So y equal to, and what is m? Slope of what? Slope of parabola? Slope of parallel chords. Good. M is slope of parallel chords. Right? Suppose y equal to 2x plus 3, right, is one of the parallel chords. One of the parallel chords. So what is m here? 2. So what will be the diameter? Y equal to 2a by m. What is value of a? A you will obtain from here, 2. And what is m? So y equal to 2 will be the equation of diameter. So basically it is just finding out a from coordinates of focus from what you call parabola, a from parabola, and m from the slope of the parallel chords. You divide 2a by m and you will get the equation of the diameter. Next. If the chord joining the points having parameters t1 and t2 passes through the focus, for focal chord, t1, t2 will always be equal to -1. See, if there is a focal chord and the chord passes through the points t1 and t2, parameter t1, t2 means what? One of the extremities will be a t1 square, 2a t1, and the other extremity will have the coordinates a t2 square, 2a t2, right? And if it is a focal chord, then this property will hold. T1, T2, the product of T1, T2 will be -1 for the focal chord. Because these conditions will later apply while solving the questions. So you have to remember these results. That for focal chord, if the extremities where the focal chord is cutting the parabola, the parameter is T1 and T2, right? Then T1, T2 will be equal to -1. Next, if the coordinates of one end of the focal chord is 80 square 280, the normal parametric form which we take. If one end of the focal chord is 80 square 280, then what will be the coordinates of the other end? A divided by t square and minus 2a divided by t. Is that clear? There is a focal chord. One end has coordinates 80 square 280. The other end will have coordinates a divided by t square minus 2a by t. Yeah. The chord of contact of the point x dash y dash with respect to the parabola y square equal to 4ax is, what is this? Y dash is equal to 2ax plus x dash. It is nothing but t equal to 0. So, and what is chord of contact? Chord of contact is, see if this is the parabola, there is a point x dash y dash. From this point you draw two tangents, right? You can draw two tangents from a point outside it to a parabola. Like this. Then you join these points, the points where the tangent is there. This PQ is known as chord of contact. From a next point, you draw two tangents, the point of contacts you join, and this chord is known as chord of contact. And this equation is same, t equal to 0. So the equation of this chord of contact will be, what will be the equation? Y dash minus 2a x plus x dash equal to 0. So there is a difference. See, this equation also represents the equation of the tangent, but then in that particular case, the point is on the parabola. Now here the point is outside the parabola. So the same equation is representing two different things. Tangent in one case and chord of contact in the other. Next. The tangent to the at the points, the tangent at the points 80 square 281, 81 square 281 and 82 square 282. The tangent at these 2 points intersect at this point, a t1 t2 and a t1 plus t2. So in parametric form we have an advantage. If you draw two tangents at these 2 points, 81 square 281 and 82 square 282, then you have to find the point of intersection. This will be the point of intersection. A t1 t2 is the x coordinate of the point of intersection and a t1 plus t2 is the y coordinate. And there is an important result. The tangent at the extremities of the focal chord will intersect at what point? They will intersect at on the directrix, and that too at right angles. You take any focal chord, see, let us take this parabola. This is the focus. PSQ is the focal chord. You draw a tangent here at this point. You draw a tangent here at this point. Right? First of all, this will be perpendicular. And the point of intersection of these two tangents will be on the directrix. This property we will be using later to solve some questions. Is that clear to you? Next, diameter to the parabola is parallel to axis. I have told you, as it is clear from the equation. If y is equal to 2a by m is the equation of diameter, it has to be parallel to the x-axis. And the semi-latus rectum of the parabola is the harmonic mean of the two segments which are divided by the axis. The semi-latus rectum of the parabola is the harmonic mean between the segments of any focal chord of the parabola made by the axis. See what this result says, if there is a focal chord. See, this is the focus. Focal chord is PSQ. What are the two parts in which the focus is dividing the focal chord? PS and SQ. So the harmonic mean of these two segments, these two parts, is equal to semi-latus rectum. Length of the semi-latus rectum is the harmonic mean of these two. So when you have, again, just see, there's a focal chord. Focal chord will be divided into two segments. Harmonic mean of these two segments is equal to semi-latus rectum. And what is harmonic mean? How to calculate harmonic mean? Twice of PS multiplied by SQ divided by, so this is equal to this divided by 2. Now let us solve some questions. Other formulas we'll do later. Given two ends of the latus rectum, the maximum number of parabolas that can be drawn. You are given the extremities of latus rectum, how many parabolas can be drawn? Draw the figure and just find out using some logic. See, let us say these are the two extremities of the latus rectum, right? Now, suppose this length is 4a. Suppose this length is 4a. So this will be 2a and this will be 2a. And what will be the coordinates of focus? A0. So either the focus can be on this side, right? See, if it is y square is equal to 4ax, so the two shapes can be like this, either this way, yeah, minus 4ax. So there will be two parabolas, one like this and the other. For both of them, the latus rectum will be the same line. Next, if the focus of the parabola is minus 2, 1, and the directrix has the equation x plus y equal to 3, then what will be the vertex? Focus of the parabola is minus 2, 1, and the directrix is also given. You have to find the vertex. See, we have to find the coordinates of the vertex, right? We have to find coordinates of V. And what is given to us? Focus is given. Let us say the focus is minus 2, 1. Focus is given and the directrix is also given, x plus y equal to 3. Listen, we are not taking this to be x and y axis. I have not drawn the axis. So this is the axis of the parabola. This is the directrix. Vertex we have to find. What is given to us is the focus and the directrix. See, one way is you can first find the equation of the parabola. If you take a point P here, xy, right? Now this distance is equal to this. And then you will solve it. You will get the equation of the parabola. And then from the equation of the parabola, you will be able to find the vertex, but that will be a lengthy process. What you can do is, you can find this equation. No, you can find this coordinates of this point. And then, since vertex is a point on the parabola, it will be equidistant from the directrix and the focus. Using this property that these two are equal, we can find the midpoint and that will be the vertex. So what you do is, you first find the equation of the axis. What will be the equation of the axis? After finding the equation of the axis, you find the point of intersection of the directrix and axis. You will get this point. Let us say this point is M. And then once you have this point M, you can find the midpoint of MS. What is slope of this directrix? -1. Right? What is slope of the axis? What is the slope here? 1. Perpendicular lines. Directrix and axis are perpendicular. So what is the equation of the axis? Equation of this axis will be what? Y minus 1 is equal to slope 1 into x minus x plus 2. Now you know the equation of the axis. You know the equation of the directrix. Solve them. Their point of intersection will give you M. X plus y equal to 3. You can write like this. Now solving these two, you just add the two. What you will get? Or subtract. Y minus 4 is equal to 2 minus y. So 2y is equal to 6. Y equal to 3. Now when y is equal to 3, what is x? X plus y is 3. So x is 0. So we get the coordinates of this point as 0, 3. Now what will be the coordinates of vertex? Find out the midpoint of these two, M and S. So -1 and 2. So what is the right option? -1 and 2. C is the right option. Is that clear? Rather than finding out the equation and then finding out the vertex, it will be easier. Since we know the directrix, its slope is -1. Slope of the axis will be 1. We have we are given the coordinates of focus. You obtain the equation of the axis. Y minus y1, slope is 1 into x minus x1. Then you have equation of these two perpendicular lines. Find their point of intersection. Solving the two equations, we get the point of intersection, which is M. And then you find the midpoint of MS. Is that clear? Next. Third question. We are given the vertex and focus. We are given the vertex. We are now given vertex and focus. And then you have to find the equation of the directrix. Use similar concept which we have just done. We are given the coordinates of vertex as well as focus. You have to find the equation of the directrix. Question third, what is given? Vertex -1, 1. focus is 2 3, vertex is -1 1. Now what you have to find? Equation of directrix. Equation of this directrix. Right? It's very simple. What is slope of this axis? Slope of axis will be what? 3 minus 1 upon 3. Slope is 2 by 3. Now what will be slope of the directrix? Minus 3 by 2. We know the slope. Now we can very easily find the coordinates of this point alpha beta. So alpha plus 2 is equal to -1, beta plus 3, right, divided by 2 is 1. So what are the coordinates of alpha and beta? Alpha is what? -4 and beta is -1. So this point is -4 -1. Right? Now what will be the equation? Yeah, equation will be y plus 1 is equal to -3 by 2 into x plus 4. So this way you can find it faster rather than finding out the equation. So this will be 2y plus 2 is equal to -3x minus 12. So the equation finally comes out to be 3x plus 2y plus 14 equal to 0. So which is this option? 3x plus 2y plus 14 equal to 0? A. So A is the right option. Now try question number 4. The length of the latest sectum of the parabola whose focal chord PSQ such that PS is 4 units and SQ is 5 units measures how much? See, basically we have to find the length of the latest sectum. We have to find the length of the latest sectum whose two parts of the focal chords are given to us. All of you have done this? I explained you how to find the focal chord. No, how to find the semi-latest rectum. So semi-latest rectum is L by 2. Let L be the length of the latest rectum. So semi-latest rectum is L by 2. It will be equal to what? PS, yeah, 2 PS multiplied by PQ divided by PS plus SQ. Now L by 2 is equal to, what is PS? 4 units. And SQ? So L is equal to 80 by 9. 40 by 9 is L by 2. So L will be 80 by 9. So the right option is D. Next, question 5th. The focus of the parabola y square equal to 8x divides the chord in the ratio. Which chord? It has to be focal chord. When the focus is dividing a chord in some ratio, it has to be focal chord. 2 is to 3. The length of the longer of the two segments you have to find. Two segments means in which the focus divides the chord. The greater of the two you have to find. This is also based on the same concept. The length of the semi-latest rectum is equal to harmonic mean of the two segments. Question 5th. y square equal to 8x. The shape will be even power of y symmetrical about x-axis. This is what? S. The ratio is 2:3. So let us say this is 2k and this is 3k. The ratio means it's not equal to 2 and 3, 2k and 3k. So we can find out the length of the latest rectum. If the equation is given to us y square equal to 8x, length of latest rectum will be what? 8. This is 4a, 4a is 8. So L by 2 is equal to twice of PS into PQ divided by PS plus PQ. So this is based on the same formula, but here you can find out the length of the latest rectum from the equation which is given to you, which is 8. So that is not what you have to find. 8 by 2 semi-latest rectum. Twice of PS is how much? 2k and 3k. PS and SQ, or yeah, SQ we will take. PS and SQ. This also you can take as PS and SQ. Right? So 2k multiplied by 3k upon 5k. So one of the k cancels out. K is equal to 5 by 3. So which is the longer of the two parts? Obviously 3k. 2k, 3k. 3k is the greater of the two. So substitute the value of k. What is k here? 5 by 3. So longer of the two segments is 5 units. So what is the right option? C. Next. The slopes of the tangents drawn from the point 1,4 to the parabola y square equal to 8x. See, there is a point which is given to you, external point 1,4. Equation of the parabola is given to you. You have to find the slopes of the tangent. Now how you will find the slope of the tangents? You cannot use the formula y1 y dash is equal to 4 into x plus x dash. We cannot use that formula because that formula is only applicable if the point is on the parabola. So if any one of you is using that formula and then finding the slope, that is not correct, because here the point 1,4 is not on the parabola. You have to find the slope of the tangents from the point 1,4 to the parabola. Here the point 1,4 is outside the parabola. So that finding out the equation of the tangent is incorrect here, applying that result. T equal to 0 will not be applicable here. So what you will do? What is the equation of the tangent? Condition of tangency is what? If y equal to mx plus c, let us say y equal to mx plus c is the tangent. Right? Now c will be equal to a by m. I have told you condition of tangency, c is equal to a by m. Now from the parabola, y square is equal to 8x, 4a is 8. What is a equal to? 2. So c will be equal to 2 by m. And what will be the equation of the tangent? y equal to mx plus c. C is 2 by m. So this is the tangent. Now how can you find the value of m? See, using the equation of the parabola, we can find a. So y equal to mx plus a by m. A is 2. So this is in terms of m only. This is the tangent. Now how to find value of m? Since this tangent is passing through the point 1, 4, therefore the coordinates of the point 1, 4 will satisfy it. Is that clear to you? Since this passes through 1, 4, in place of x and y, you substitute this and then find out value of m. You will have a quadratic equation. See, from a point outside the parabola, two tangents will be drawn. So there will be two values of slope. Is that clear to you? We assume the tangent to be y equal to mx plus c. C is equal to a by m, right? A is given to us. A we can find from the value of from the equation of the parabola. So now since this passes through 1, 4, in place of y you write 4 and in place of x you write 1. So multiplying by m, what you will get? 4m is equal to m square plus 2, right? So m square minus 4m plus 2 is equal to 0. You find out the value of m. B is the right answer. Chaliye next, question 7th. The tangent to the parabola y square equal to 4ax at the point x1 y1 meets the parabola y square is equal to 4a x plus b at the points q and r. You have to find the midpoint of qr. Question 7th. See the tangent to the first parabola y square equal to 4ax. You find the equation of the tangent because the point at x1 y1 means that the point is lying on the parabola. You find the equation of the tangent to this parabola at the point x1 y1. That is one line you will get equation of tangent, and that tangent meets the other parabola in 2 points at q and r. You have to find the midpoint of q. Try it out. I'll give you some time. So first, y square is 4ax. There's a point. Let us say this is a point x1 y1. The tangent at this particular point. What is the equation of tangent? There, yeah, y1 minus 2a x plus x1. This is the equation of tangent. This tangent meets another parabola which is given to you, y square equal to 4ax plus b at q and r. Let us say the other parabola is this, y square is equal to 4a x plus b. So you know the shapes are, see the equation, y square is 4ax, this is also y square is 4ax. But what will happen to the vertex? The vertex will shift. Where it will shift? B units to the left. B units to the left. So if the vertex of this parabola is this, which is what? 0, 0. The vertex of this parabola will be x coordinate will be minus b. So the vertex will be minus b0. So it is just shifting of the parabola. Now this point is, let us say, which 2 points they are given? At q and r. This is q, this is r. So you can assume midpoint. Let midpoint of this be alpha beta, because what you have to find out? You have to find the midpoint. So let midpoint of this chord QR is alpha beta, right? Midpoint of QR is alpha beta. Now can you find the equation of this chord? Can you find equation of QR? How to find equation of a chord whose midpoint is given? S1 equal to T, very good. You apply that formula S1 equal to T. Applying the formula S1 equal to T, you will get the equation of the chord QR. Equation of chord QR whose midpoint is what? Whose midpoint is alpha beta is S1 equal to T. What is S1? You will substitute in this equation, you will substitute alpha for x and beta for y. That is your S1. So you will get beta square minus 4a. In place of x, you will write alpha. Alpha plus b. Is that clear to you? S1 value. In place of y, I have written beta, and in place of x, I have written alpha. And this will be equal to t. What will be t? Y dash. So y beta, or you can write beta y minus 4a, right? Or you can just first open it up, 4ax plus 4ab, 4ax plus 4ab. So now here what you can write is minus, because I am shifting it to the other side. So minus 2a, and in place of 2x, what will be writing? In place of 2x, what will be writing? X plus alpha. This is a difficult question. I agree it's difficult, but still. And what about this? Constant will remain as it is. Is that clear to you? So what I have done is, see, I am finding the equation of the same line. The same line is a tangent to this parabola y square equal to 4ax. So when I am finding the equation of this tangent, which is t equal to 0 at the point x1, y1, I am getting this. This is the equation of tangent. Now the line is same. When I am finding the equation of the chord QR whose midpoint is given, alpha beta use करके I am finding the equation of the chord QR. That is S1 equal to T. So in place of first you write it like this, and then in place of y I am substituting beta, in place of x I am substituting alpha. That is S1 square. right? S1, and that is equal to T. T is this. Now you simplify this, and now when two equations represents the same line, what is the condition? What is the condition for two equations to represent the same line? What will be equal? Listen, if you have this equation a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, and they represent the same straight line, a1 upon a2, b1 upon b2. So this is what you will do. Finally, see what is coordinate of y here, coefficient of y, y1. What is coefficient of y here? You simplify this. Ratio of the coefficients of y is equal to ratio of the coefficients of x is equal to the ratio of constants. And then you will obtain value of what? Alpha and beta. Got it? If you want, you can try it out. And the answer is coming out to be A. Yeah. That means this point will be the midpoint of the chord. X1, Y1. Next. 10, 10. Now see this. The equation for lambda x square plus 4xy plus y square plus lambda x plus 3y plus 2 equal to 0 represents the parabola if lambda is equal to what? This is the equation of parabola if lambda is we have done 8th and 9th. Prior to this, 8th, 7th, we have done 8th, 8th नहीं 8th है मे बी इसके बाद आया है कुछ. चलो we'll do 10th first. This equation represents the parabola if lambda is एक पेज है इसे कंफर्म कर लो एक और नीचे भी. See what is this equation? This is a general equation of second degree, and you know general equation of second degree can represent the conic section as well as pair of straight lines also. Now you must know when is the general equation of second degree representing a parabola. वैसा करिए ना यही नहीं मानेंगे पेपर इसी से हाँ पेजेस See, first of all, there is a condition for the general equation of second degree to represent a parabola. That condition is ax square. First, the general equation is this ax square right. Now there is a determinant delta which you can write like this. On expanding this, you will get ABC plus 2 this is delta, right? Now this is not equal to 0. For conic section, this quantity will not be equal to 0. And for pair of straight lines, this expression will be equal to 0. Right? Now, it's not a question of pair of straight lines. So first thing is this is not equal to 0. And for parabola specific, h square is equal to AB. So this will not help us. This delta is not required, but this is the condition that delta is not, for conic section, delta is not equal to 0. And conic section means for parabola, ellipse, hyperbola, for all three this quantity will not be equal to 0. And for parabola, h square will be equal to AB. Now if you look at this question, what is value of A? What is value of A? Coefficient of x square. See, you look from here, coefficient of x square is A. So A is lambda. What is value of h? How you will obtain h? Take coefficient of xy and divide by 2. So if you take coefficient of xy and divide by 2, you get 2. And what about b? Coefficient of y square 1. So h square equal to ab will give you 4 equal to. So what is the answer? B. Next question 11th. कोई बात नहीं, ऐसे ही बता देंगे, टाइम मिला तो यही बता देंगे. Now the focus of the parabola y minus k square equal to 4x minus h always lies between the two lines x plus y equal to 1 and x plus y equal to 3. Then you have to find what is the range of h plus k. Try this. The focus of this parabola always lies between these two lines. Now what can you say about the value of h and k? Sum of the two, h plus k. Now see, this is also a very interesting question. This is x-axis, y-axis, right? You draw these two lines. X plus y equal to 1 will be like this and x plus y equal to 3 will be like this. The focus of this parabola lies between these two lines. So you can have the parabola like this. This is the vertex and let us say this is the focus. Focus lies between these two lines, x plus y minus 3 equal to 0 and x plus y minus 1 equal to 0. Now can you tell me how to find the coordinates of the focus in this case? So what we do is y minus k whole square is equal to 4x minus h, right? This concept is based on shifting the origin. What we do is we convert it into standard form. How we convert it into standard form? Let y minus k will be equal to capital Y and x minus h be equal to capital X. So if you make this substitution, this equation will become y square is equal to 4x. Is that clear? Y square is equal to 4x. Now tell me what will be the coordinates of focus in this case? Focus we obtain by just dividing the coefficient of linear term by 4 in case of standard form. So coordinates of focus will be 1, 0. This is focus relative to the new axis because we have shifted the origin. If you want to find the focus for the original axis, what we'll do is we'll find value of small x and small y. In place of capital Y, this is capital X, this is capital Y. In place of capital Y, I'll put 0. And what is the coordinate, x coordinate? Capital X, 1. You substitute it back. Is that all right? So now what are the values of y and x? Small x will be small x and y, original axis, right? So what is value of small x? 1 plus h or h plus 1. And what is value of small y? So this is how we find the coordinates of focus or any other equation by shifting the origin, by converting into standard form. Now this is a focus. Now h plus 1 and k h plus 1 k lies between these two lines. Now what you will apply to find the condition? Because there can be so many different cases. Now another concept is used here. See, if there is a line, let us consider this line x plus y, same line I can take x plus y equal to 3, right? Now one point is 0, 0, and let us say another point I am taking here as 1, 1. It will be below the line, somewhere here. Is that clear? Now, if you substitute the coordinate of this point in this, what you get? If you substitute 0, 0 in this, and then you substitute 1, 1, you will observe that value of this expression comes out to be negative in both the cases, if the origin and the point are on the same side. And if both are coming out to be negative, by substituting this coordinates in this point, it is coming out to be negative. Now if you substitute a point, let us say I am taking the point 3, 3. Origin is on below the line and 3, 3 is above the line. So what will happen in this case? Right here, when I substitute, I'll get positive, and origin I'll again get negative. So I'll use this concept. In this particular case, this point is above the line. So when I'll substitute this point in this, it will be greater than 0. And if I substitute the coordinates of this point in this line, it will be less than 0. So use this concept to find out the range of h and k. So finally, if I substitute h plus 1 and k in this line, in place of x you put h plus 1, right? In place, this is x plus 1, h plus 1 in place of x. In place of y I am substituting k. The point is above, on the upper side of the, on the other side of the origin, right? Minus 1. So this will come out to be what? Positive. So h plus k, this cancels out, is greater than 0. Now similarly, since the focus for as relative to this line is towards the origin, you can say like this: focus relative to this line is towards the origin. So in place of x you put h plus 1, in place of y you put k minus 3. So this will be less than 0 because it is towards the origin. So h plus k, this is minus 2 and it's less than 2. So yeah, combining these two you will get h plus k is greater than 0 and less than 2. See how simple, it was a simple question, but then this concept which has come in, and then the concept of shifting the origin, both of them are important. So finally what's the answer? H plus k lies between 0 and 2. So A. Question 12. If AB is the focal chord of the parabola whose focus is S, AS1 is L1, what is BS? See, again you shift the origin, at least you find out the focus. This is based on that same concept. Length of the later sectum by 2 is harmonic mean of the two parts of the focal chord. So what you have to do is you first find the length of the later sectum. First you find the length of the later sectum. How you will find the length of the later sectum? X square minus 2x plus y minus 2 equal to 0. Right? X square minus 2x is equal to 2 minus y. So what I am doing is completing the squares. How to complete the square here? I am adding 1. Right? I'll add 1 on both sides. So this is what? X minus 1 whole square. And this is what? Minus, you take minus common. This is 3 minus y, right? So if you take minus out, it will be y minus 3. Now what I have told you, equation is what? X square is equal to minus y. So here, see, just by looking at it, you can say vertex is 0, 0. But if you have to go to the original axis, the vertex will be what? 1. You equate this equal to 0, 1 and 3. So what is the length of the later sectum? 1. This length will not change. This length will not change. So directly also you can find out the value of the later sectum. So length of the later sectum will be 1. Right? So what is half of it? And now you can apply that same result. The two parts are what? AS and BS. So twice of AS is given to us as L1. And BS you have to find. So what is the final answer? I think it's the D part. You can try it out now. Just cross multiply and find value of L. Find value of BS from here. It will come in terms of L1. L1 plus BS is equal to 4 L1 BS. Take these two on the one side. So L1 is equal to BS 1 minus 4 L1. Right? So BS is coming out to be L1 upon 1 minus 4 L1. Maybe there's a difference of sign. 4L1 minus 1. D is the right option. Next. The curve represented by x equal to 3 cos t plus sin t, y equal to 4 cos t minus sin t is an ellipse, parabola, hyperbola, circle. See what you will do in this case? Try and eliminate the parameter. And then when you will get the equation in that other form, then you can find out what it is. You have to eliminate sin t cos t. Just find the sum of their squares. Square the two equations and find their sum. तो वो इसमें आएगा वो पेज या ऐसे ही करना है? इसी से करना है. See, eliminating sin t cos t, it will finally take shape of an ellipse. It will finally be of the form x square by a square plus y square upon b square equal to 1. Next. Now this question, we are given these 2 points, at square 280 and ap square 2ap. These are extremities of the focal chord of the parabola, right? The focal chord of the parabola, y square equal to 4ax. Then what will be the value of which one of them is correct? I told you a condition for focal chord of a parabola. What happens? At square 280, ap square 2ap. So what are the parameters? T and P. And for focal chord, what is the condition? I have told you if at1 square 2at1 and at2 square 2at2 are the extremities of focal chord of the parabola, then what is the condition? See, just look at your notes. If the extremities of the focal chord are given to you, having parameter T1 and T2, what is value of T1, T2? -1. You apply that result. No calculations are needed in this. See, one of the point is at square 280. So the parameter is T. And for the other point, the parameter is P. So what is T into P? So what is the correct answer? Tp plus 1 equal to 0. Is that clear to you? So the right option is B. Now one more question. We have time for 1 minute. I'll just read the question and the concept to solve it. The vertex of the parabola is given to you, A0. Vertex is A0. So this is not the y-axis. Vertex is A0. And its directrix is also given to you, x plus y equal to 3a. So we are not assuming these to be the axes. This is the directrix, this is the vertex. You have to find the equation of the parabola. How you will find the equation of the parabola? See, to find the equation of the parabola, you have to find the coordinates of focus. What will do to find the coordinates of focus? You will find equation of the axis. You are given the equation of the directrix. Your slope is -1. Slope of the axis is 1. Using the slope and this point A0, you find the equation of the axis. You solve these two lines and obtain this point. Once you have this point as well as the vertex, focus you can find. And once you have the focus, distance, you take an arbitrary point xy, its distance from focus will be its distance from directrix. Solving this result equation, you will get the equation of the. That's it.